Hello and welcome to my channel Java tutorial. In this particular video we are going to see the process of extracting digits from a number and few programs based on it. The content is based on the CISC syllabus for standard 9 and 10. Now what is digit extraction? How it works? Digit extraction is the process of separating out each digits from a given number and carrying out different operations with the digits. So we know that a number is a collection of digits, and if we can separate out the digits and then carry out different operations with the digits of the number, we call it as a digit extraction program. So it means separating out the digits of a number. So let us take an example. Suppose the number is 7925. So we can see it is a 4-digit number. So how are we going to separate out these individual digits from the number? So to separate out the digit, what we can do is we can divide the number by 10, which will give the last digit as the remainder. So any number, if you take and divide it by 10, the remainder will always be the last digit. You can think of any number, you divide it by 10, always the last digit will be the remainder. And the quotient, we get the number leaving out the last digit. So if I divide 7925 by 10, the remainder will be 5 and the quotient will be 792. So this is the first digit from the right hand side of the number which is extracted. Now what we can do is we can repeat this process. That is, we divide 7925 by 10, that is modular division. The percentage sign is called the modular division, we get 5. And if I carry out the normal division using slash, I'll get 792. If I repeat the process with 792, again divided by 10, I'll get the remainder 2. And the quotient, I'll get 79. 79 if I divide by 10, I'll get 9. The quotient I'll get as 7. 7 if I divide by 10, the remainder I'll get as 7. And the quotient I'll get as 0. So we can see we started from the number 7925, and in the process of repeated division, that is modulus as well as the normal division, the number reduces to 0. So the digits, we get 5, 2, 9 and 7 in the reverse order. So always when you are extracting the digits will get in the reverse order of the number. So what will be the code for it? So the first thing that we did was n modulus 10, which we consider as d, the digit, which we consider as d, the digit. The next is we updated the value of n as n is equal to n/10. And how many times are we going to repeat this? We are going to repeat this process till the number is greater than 0, that is while n is greater than 0. Now this is the part where the code will appear depending upon what is to be done with the digit. So obviously when you are writing a digit extraction program, you will be given a task to perform certain operation on the digit. This is the place where that particular code will appear. The remaining part will remain exactly the same. So let us see an example to find the sum of the digits. So we are going to take a number and then we are going to find the sum of the digits. So I've taken int n is equal to 4523, d and s is equal to 0. For separating out the digits, what we write? N modulus 10. For updating the digits, we write n is equal to n/10. And we repeat this process till the number is greater than 0. And then we write s is equal to s plus d. Now see, you can see this code, s is equal to s plus d. This is the code that is going to find the sum of the digits, when s is equal to 0, which I have taken initially, and then n is equal to n/10. Moving forward, let us see some of the application programs based on the concept of digit extraction. The first program that we are going to see is to find the largest and the smallest digit in a number. To find the largest and the smallest digit in a number, obviously I'll be taking two variables, max and mean. Max should always be initialized to the smallest possible digit so that every other digit is larger than that, and mean should be initialized to the largest possible digit so that every other value is smaller than that. Next, we take the number as input. N is equal to sc.nextInt. We take the loop while n is greater than 0. D is equal to n modulus 10. So we get the digit. Now we put the checking over here. If D is greater than max, that is the current digit is greater than the max that we have taken, max updates to D. And the same thing, if D is less than mean, mean updates to D. And then n is equal to n/10. At the end, we can just print the largest digit max and the smallest digit as mean. The next program is to count the number of digits in a number. The process the same. We take a class. The class name is count. I have taken a counter C as 0, which will keep updating, which will keep increasing by 1 every time I get a digit. So while n is greater than 0, D is equal to n modulus 10, C++. C++ is working as what? It is working as a counter which is increasing by 1 every time a digit is extracted. And then n is equal to n/10. System.out.println, the number of digit is C. The next program we are going to see how to reverse a number. To reverse a number, I have named the class as reverse. I have taken a variable r is equal to 0, r for storing the reverse of the number. We take a number as input. We take the while loop, D is equal to n modulus 10. Now you can see I have written a statement over here, r is equal to r into 10 plus D. Now this is the statement that will reverse the given number. We'll try to understand with the help of an example how it works. Say we take the number as 123. So the first digit that we'll get is 3. Now we have taken r is equal to r into 10 plus D. So r value I have initialized to 0. So 0 into 10 is 0 plus 3. So r becomes 3. When the process is repeated with the value 12, I'll get the next digit as 2. Now the previous value of r we got is 3. So r into 10, that is 3 into 10, 30 plus 2, I'll get it as 32. The number reduces to 1. We repeat the process. I'll get the next digit as 1. Now the last value of r I got as 32. So 32 into 10, that is 320 plus 1 is 321. And the number reduces back to 0. So you can see the number we started n as 123. At the end of this, r becomes 321, which is the reverse of n, but at the same time the value of n has become 0. So the reverse is r, which is 321. So this is the code that will help you to reverse a number which you have taken as input from the user. Next, we check whether a number is palindrome or not. Now what is a palindrome number? A number is said to be palindrome if it is same as its reverse. That means after reversing the number is exactly the same. Say for example 121. If I reverse it, I'll get back 121. So it is said to be a palindromic number. So obviously when we are checking for a number to be palindrome, the first thing that we need to do is to reverse it. So let us see the code. The code will be exactly the same. The name I have given as palindrome. I have taken a variable r as 0 and I have taken another variable m. The variable r will be used to store the reverse of the number as we saw in the previous program. Now what I have done is I have taken the variable m and initialized the value of n to m. That means I have copied the value of n and stored it in m. What is the purpose? The purpose is, as we have seen that the the while loop executes till the value of n is greater than 0. So that means that the while, by the time the while loop will come to a will come to end, the value of n will be 0. That means you will lose your original value. But palindrome is about checking the reverse with the original value. So if you lose the original value, and then if you put a checking comparing the original value with the reverse, you will always get it to be false. So I have copied it and stored in the variable m. The basic code is the same. We have reversed the number. Now at the end of reversing, I have just checked if the reverse of the number, that is r, is equal to m. M is what? M is the copied value of n, because n will become 0. So I have copied it and stored it m, and then I am checking it with m. If the values are equal, we call it as a palindromic number, else it is not a palindromic number. So this is how you check whether a number is palindromic or not. This is a program that removes zeros from a number. So let us see the code. I have named the class as number, public void main. I have taken d, n, r as 0 and I as 0. R will be storing the result. Here R represents result, which will be the number where the zeros have been removed. So as you can see in the code, what I have done, I have taken the digit d is equal to n modulus 10, and I have checked that if the digit is not 0, then only it will be added up to the result. So let us see the working of it. Say the number is 1003. So if n is greater than 0, I'll get the first digit as 3. 3 is not equal to 0, so r will be executed, which is 3 into 10 to the power 0, because the value of I is 0. So 3 into 10 to the power 0 is 10 to the power 0 is 1. So 3 into 1 is 3, and the value of r initially is 0. So 3 into 10 to the power 1 plus r becomes 3. And I plus plus, the value of I have taken 0, so I becomes 1. And the remainder, that is the quotient, is 100. We repeat the process with a value 100. So I'll get the next digit as 0. Now 0, because d is, the condition was d not equal to 0, but because d has become 0, so the statement r is equal to d asterisk math.power 10 comma I plus r will not be executed. So we'll continue with the next value, that is 10, and again I'll get the next digit as 10. So again, this particular part, the if conditional part, will not execute, will proceed. The last digit that I'll get is 1. Now 1 is not equal to 0, so that is condition is satisfied. So r is equal to 1, that is d, into 10 to the power 1, because the value of I had become 1 in the first stage. So 10 to the power 1, that is 10. So 10 into 1 is 10, plus the last value of r was 3. So 10 to the power 1 into 1, that is 10, plus 3, I'll get it as 13. And n becomes 0. So you can see the result is r, which is equal to 13. So 1003, if I remove the zeros from the number, I'll be getting it as 13. So this is a small program that will remove the zeros from the number. There's a few more questions which you can solve. The first question says, check if a number is Armstrong. A number is said to be Armstrong if the sum of the cube of the digits is equal to the number. So what you are going to do is, similarly, you are going to extract the digits from the number, and with the digits that you get, that is d, you are going to find the sum of the cube of it. That is sum, you take a variable s is equal to 0, and then within the loop where you are getting the digits, write it as s plus d asterisk d, that is cube of the digits. Next, check if a number is a duck number. A number is said to be a duck if it has any zeros in it. So simply count the number of zeros. If the count is greater than 0, that means it is not a duck number. If the count remains if a number is duck number, it's okay. So a duck number is one which has zeros in it. So if the count is greater than 0, then we call it as a duck number. So you simply count how many zeros are there. Suppose there are 4 zeros, so the value of count will be 4. In that case, it will be called as a duck number. Check if the sum of the digit of the number is equal to the product of the digit. So the same way, what you're going to do, you're going to find the sum of the digit as well as product of the digit within the same loop. For finding the sum, we already have seen, we take a variable s, initialize it to 0. For finding the product, take a variable, say p, and initialize it to 1. And within the loop, you find the product as p is equal to p asterisk d. And then check if the sum of the factorial of the digit is equal to the number. So what is factorial? Factorial is the product of natural numbers up to the given number. So if I want to find the factorial of d, I have to find the product of all natural numbers up to d. And then once I find the factorial, we'll find the sum of the factorial of the digits and then check whether it is equal to the number. So these are some of the programs which you can try out at home, which you can practice at home on your own. So with that, we come to the end of this video, which was based on extracting digits from a number and carrying out different operations on the extracted digits. You can post any questions regarding this video in the comment section of the video. Thank you for watching.